Okay, pause and copy. All right. So, why? Why? Why do we care? Why? Why? Well, we are going to use this in a variety of ways. First of all, imagine you have a wrench. I'm going to try to draw a wrench. Bear with me. Don't judge me. Oh dear, it's going badly already. Here's the arm of the wrench. Oh my gosh. Okay, something like this. Okay, not so bad. Let's say the same thing over here. Oh no, this is not. Oh no. Oh dear. Oh dear. Okay, wrench. So you have a wrench and you have say a bolt or a nut or whatever right here. And when you're doing this wrenching, when you're doing this, you're using this wrench to tighten or loosen this bolt. Typically, you're applying a force over here. Let's say you're applying a force right here. You have some force that you're applying, F. And then you have this vector that goes like that. We'll call that X. Now, it's useful in, say, mechanical engineering to understand how much rotational force are you applying. Like how much, well, the word we use is torque. How much torque are you applying to the bolt here? Okay, it's going to depend on your X, and it's going to depend on whether your force is going in the best direction. And it turns out that torque, in the 3D case, is going to be the force vector cross product with the distance vector there. So we're going to use the cross product for torque in R3. Okay, important, yeah, maybe underline this again. R3 is the only place where the cross product exists. It does not exist in R4 or R2. Torque, there's one thing. What else? Also, we're going to see how this applies to finding volumes of, well, they're called parallel pipets. Roughly, these are parallelograms. In R3, so three-dimensional parallelograms. You can call them parallelepipeds. So the cross product will come in there too. So anyways, lots of applications. We're not just trying to torture you here, though it is fun to torture students. Okay, let's do some examples here to see how this thing is computed. Well, the definition I will use, which is a bit different than what the textbook does, is that the cross product is in terms of a determinant. Now I'm going to put the vectors I, j, and k here. The vector I is the vector 1, 0, 0. J is 0, 1, 0. K is 0, 0, 1. So the definition is U cross V is going to be a determinant, ijk across the top. Which is kind of weird because these are vectors, but it's just a kind of a useful notation to use. And then you take your, basically I'm going to take this vector and put it across here, and I'm going to take this vector and put it across here. But more generally, you have U1, U2, U3, V1, V2, V3. Okay, what I mean by that is that this is V1, this is V2, this is V3, and this is U1 is the first component, U2, U3.